Welcome to Void Realities. If you're awake when the world sleeps, you've found the right place. Here, the lines between dreams and reality blur, and you can drift away into a world that feels like it's just for you. No rush, no pressure. Just a space for you to unwind, let go of the noise, and find calm in the quiet of the night. Whether you're seeking peace, wonder, or something to help guide you into sleep, Void Realities is your escape. Sit back, relax, and let your mind wander to the edge of the unknown. Welcome to the void. Why moving faster lets you age, slower your heartbeat as the first clock. You drift into the thought of a universe that never stops breathing outward. Galaxies slip away like lanterns carried by an invisible tide. You are part of that tide, your atoms moving gently with it. It is not a rush, but an endless sigh. Your heartbeat is the first sound you ever knew. Long before you learned words, before you understood the idea of days and nights, that steady thud marked the rhythm of your life. It is the drum of your existence, a quiet personal metronome that no one else hears in quite the same way. Even now, as you lie still, your heart measures the passing of time for you. Not in numbers, not in minutes or seconds, but in a more intimate way. Each beat is a gentle knock on the door of the present moment, a reminder that you are here. The world has many clocks, atomic ones that never miss a fraction of a second, ancient sundials that follow the shadow's slow crawl, hourglasses that let sand fall like whispered secrets. But your heart was your first. It ticks without gears, without batteries, without needing to be wound. It is alive, and it keeps time not just for you, but with you. Think of how it changes with your feelings. When you are calm, your heart slows, stretching the space between its notes. When you are startled or excited, it races, shortening the pauses until they nearly vanish. Time for you is elastic, and your heartbeat is its proof. If you were to count the beats, you could estimate how much time has passed, but you rarely do. Instead, your body listens quietly, trusting this internal rhythm to guide you through the hours without needing to see the hands of a clock. Imagine now that you are floating in darkness. There is no sunrise, no sunset, only the soft thump of your own heart. Here you would know time only by the spaces between those sounds. It is a reminder that before humans built calendars and divided days into neat boxes, time was felt, not measured. Your heart doesn't follow the strict laws of human-made timekeeping. It bends to your life. Run up a hill and it will surge ahead, making the world seem more immediate. Sit under a tree and it will slow, letting the moment linger. Your heart tells a different kind of time, a personal one. In a way, this is the earliest lesson in relativity you've ever had, even if you didn't know the word for it. Time, as you live it, is not a constant stream. It shifts with your body, your mind, your surroundings, and though scientists can explain this with equations, you've always known it by feel. Across the universe, time is kept in countless ways. A pulsar, a collapsed star spinning faster than a kitchen blender, beams light into space with the accuracy of an atomic clock. The Earth turns, giving us the length of a day. Atoms vibrate in laboratories to define the official second. But none of these matter to you in this quiet moment, because your first and truest clock beats just beneath your hand. The beauty of this clock is that it is yours alone. It began before you could see light, before you could hear the world outside. And it will keep going faithfully through the laughter, the quiet, and the years you have yet to live. Now picture that heartbeat not just as yours, but as part of a greater rhythm. Your pulse is tied invisibly to the pull of the moon on the seas, to the turning of the earth, to the slow drifting apart of galaxies. You are not separate from these vast motions, you are woven into them. Every atom in your body has traveled through time in its own way, riding light, falling through gravity, colliding and reuniting. And here they are, gathered in you, marking the moment with a single steady beat. When you place your hand over your chest, you are touching the oldest, most honest clock you will ever know. It doesn't care about appointments or alarms. It tells you only this: you are here now. You can feel the difference between one beat and the next, the pause where the whole universe seems to wait with you. That pause is not empty. It's a quiet, a stillness in which everything rests before moving forward again. And in that stillness you might notice something: the way the air moves slowly in and out of your lungs, the faint hum of life around you, the sense that you are part of a larger breathing, a breathing that belongs to the cosmos itself, because the universe too has a rhythm. It expands in a slow, patient way, carrying stars and planets outward as if exhaling. And just like your heart, it has been doing this since before you existed, and it will go on long after you are gone. Your heartbeat then is more than your own. It's a note in the great music of existence, a song that began before you and will continue beyond you. As you rest in this thought, you realize that your personal time and the universe's time are not entirely separate. They are different tempos of the same melody. And while the universe moves on its vast, slow beat, you carry a quicker, warmer rhythm within you. One day you might find yourself wondering how these two tempos, yours and the cosmos's, speak to each other. What happens when the pace of your life changes? When your speed shifts and your time begins to stretch or shrink? That is where our journey will lead next, to the strange and beautiful idea that the faster you move, the slower you age, and the more your clock becomes unlike anyone else's. When seconds are not the same. Everywhere you were taught that a second is always the same. But the universe smiles at this idea. Some seconds are long and lazy, others are quick and restless. They change with your speed, with the pull of the ground beneath you, with the shape of space itself. Time is not a single river, but many streams flowing at different speeds. A second feels like such a simple thing. It's the click of a clock, the beat between two footsteps, the blink of an eye. You've lived inside seconds for as long as you can remember, never doubting that they are the same for everyone, everywhere. But the universe doesn't keep time the way humans do. It has its own rules, quiet, subtle, and strangely beautiful. Rules that say a second in one place might not match a second somewhere else. Rules that stretch and squeeze the rhythm of reality without asking your permission. Imagine you are standing still, watching a friend walk past you. They glance at their watch, you glance at yours. To your eyes, both seconds tick in perfect harmony. But if your friend starts running, and if you could see deeply enough into the truth of time, you would notice something strange. Their watch to you is ticking a little more slowly. It's not a trick of the eye, it's not a malfunction, it's the way the universe works. This is one of the soft secrets of Einstein's relativity. Time, like a living thing, changes shape when you move. The faster you go, the more your seconds stretch out. Your own clock still feels normal to you. You never feel time slowing inside your own body. But from the outside, you have entered a slightly different world. And it's not only speed that bends time. The pull of gravity, the invisible tether that keeps your feet on the ground, also has its say. The deeper you stand in a gravity well, the slower your seconds pass compared to someone higher up. It's as though gravity holds onto time as tightly as it holds onto you. Consider the difference between a clock on the top floor of a skyscraper and a clock in the basement. The one higher up is a little freer from Earth's pull, and so it ticks a little faster. Not enough to notice in your daily life, but enough that physicists must account for it when designing satellites, GPS systems, and spacecraft. If they didn't, the maps on your phone would drift and your navigation would lead you astray. We live surrounded by these invisible variations, and yet we move through our days as if time were absolute. It's easier that way. The truth that your seconds are not exactly my seconds is too gentle and too small for ordinary life to feel. And yet the moment you start to think about it, the idea opens like a door. You begin to wonder how many timelines are weaving around you at this very instant. The bird flying overhead is in one, the airplane crossing the sky is in another. Astronauts orbiting far above are living in yet another version of now. None of these timelines are wrong. They are all equally real, each flowing according to the speed and gravity shaping it. And you, right here, with your heart keeping its steady beat, are part of that great interwoven pattern. It can be tempting to think of time as a single river, wide and unchanging, flowing past every shore in the same way. But that river is a trick of perspective. In truth, it's more like a network of streams, some rushing, some drifting, all twisting and bending in ways you cannot see without looking closely. And sometimes, those streams meet again. You could travel through one path of seconds, and your friend through another, and still find yourselves together, but with different numbers on your clocks, a reunion in space but not in time. In the quiet of night, you might feel this thought the way you feel a dream, something just beyond the edges of waking logic. How can your seconds be different from someone else's if you are standing right next to them? The answer is that the difference is so small, you will never sense it without tools built to measure the universe's whisper. But the difference is there. And this is what makes time so strange. It is both personal and universal. Personal because it bends itself around your life's motion, your place, your gravity. Universal because every being, every planet, every galaxy lives by these same laws. Somewhere far away, on a star's edge or in the darkness between galaxies, other seconds are flowing. Longer, shorter, softer. Seconds you will never feel, but that still belong to the same cosmic tapestry as your own. And here is where curiosity begins to stir. If your seconds can change, and if speed or gravity can stretch them, then what happens when you push these effects to their limits? How far can you bend a second before it becomes something unrecognizable? That is where our journey turns next, toward the mind that first uncovered this truth and the gift he left us, the understanding that time itself is not a rigid ruler, but a living, flexible thread woven through the fabric of space. Einstein's gift, the relativity of time. Einstein's mind saw what others could not. Time is not a fixed drumbeat. It stretches, curls, and slows, depending on your speed and where you stand in the universe. He gave us a key to a hidden dimension, a way to see time not as a ruler, but as a living thread. Tonight we walk with him through the quiet corridors of this idea. In the early years of the 20th century, the world was already filled with clocks. Railway stations depended on them. Factories worked by their rhythm. People believed time was a constant, as steady as the turning of the earth. If you and I each had a watch, they would agree, and that was the end of it. But in 1905, a young patent clerk named Albert Einstein began to wonder what would happen if you took those clocks on a journey, not just across towns or oceans, but into the very fabric of space itself. He asked questions most people never thought to ask. What if you moved as fast as light? What if the rules of motion and time were not separate, but part of the same dance? From these questions came an idea so gentle yet so disruptive that it would bend the way humanity thought forever. Einstein's special theory of relativity told us time is not the same for everyone. It can run slower for the traveler and faster for the one who stays behind. Think of a sheet of fabric stretched across a frame. Most people imagine time as the threads running evenly from one side to the other. But Einstein saw that the fabric could ripple, sag, and twist. Speed could pull it taut in one place and loosen it in another. Gravity could press it down like a heavy hand, and within that shifting fabric, our clocks and our lives quietly adjust. To him, space and time were not two separate arenas where events unfolded. They were one thing, space-time, a single four-dimensional stage where every movement in space affects the flow of time. It is a difficult picture to hold in your mind because our senses are not built to feel it. You cannot walk down the street and sense your seconds lengthening or shrinking. Your body always tells you that your time is normal, no matter how you move. But the beauty of Einstein's gift is that it lets us see beyond our senses. We can imagine two people. One staying home, one traveling quickly, meeting again and discovering their watches disagree. We can understand why GPS satellites far above Earth tick differently than the clocks in your pocket, and why they must be corrected daily to keep your maps from wandering. Einstein's insight also opened the door to understanding the universe itself. It explained why light always seems to move at the same speed, no matter how fast you chase it. It showed that time and distance are not absolute. They depend on the observer, and it hinted at the strange truth that moving through space means moving differently through time. He did not arrive at this idea through complex machinery or giant telescopes. He carried it in thought experiments, quiet, vivid stories he played out in his mind. He imagined chasing a beam of light. He imagined two lightning strikes hitting opposite ends of a moving train, and two people, one on the train, one on the platform, disagreeing about which came first. From these imagined worlds, he built a theory that matched reality more precisely than anything before it. For over a century now, experiments have confirmed his vision. High-speed jets carrying atomic clocks have shown time dilation is real. Particles in accelerators live longer when moving faster, proof that their internal clocks have slowed. Astronauts in orbit, traveling at thousands of kilometers per hour, age a tiny fraction less than we do on Earth. And yet, Einstein's relativity is more than equations and measurements. It's a reminder that the universe is softer and stranger than we expect. We live in a reality where your now and mine can be different, where the same journey takes different amounts of time, depending on how you travel. Time, in this view, is not a rigid tick of a cosmic metronome. It's a flexible, living thread woven into the vast tapestry of existence. Einstein's gift was not just knowledge, but perspective. He showed us that certainty, the belief that a second is always a second, is an illusion born of our limited view. And when we let go of that illusion, the world becomes richer, more fluid, more alive. As you lie here feeling your own heartbeat, you are also drifting through space-time. Your motion, your position, the pull of the earth beneath you, all are shaping the way your seconds pass. You may never notice the difference, but it is there, a hidden signature of your place in the cosmos. Now, another question stirs in the quiet. If moving changes time, then what happens when we take a clock, or a human heart, and set it in motion, not in thought experiments, but in reality? What stories do these traveling clocks have to tell when they return home? That is where we will wander next, into the world of moving clocks and the subtle ways they reveal the truth of time's stretch. Clocks on the move, two clocks, born together in the same moment, can grow apart without ever breaking. Move one across the world, or send it into the sky, and it will quietly disagree with the other. This difference is invisible to the eye, but the universe keeps perfect record. Tonight you listen to the slow conversation between clocks that travel and clocks that stay. Imagine you have two identical clocks. You set them side by side on a table, their ticks falling into perfect harmony. For a while, they live the same life, breathing the same air, held by the same gravity, moving only with the turning of the earth beneath them. In this shared stillness, their seconds match exactly. Now you take one clock and place it aboard a fast-moving airplane. It cuts through clouds and crosses oceans while its twin remains quietly on your desk. To both clocks, nothing seems unusual. Each feels its own steady pulse of seconds. But when the traveling clock returns, something remarkable is revealed. Its time is behind. The difference is tiny, and maybe just billionths of a second, but it is real. The moving clock has lived a slightly slower life. It's as if it has taken a gentler path through time, stretching its seconds just enough to leave a faint, measurable gap. This is not science fiction. It has been tested many times. In 1971, physicists flew atomic clocks on commercial jets eastward and westward around the globe. When compared to clocks that stayed on the ground, the airborne ones no longer agreed. The difference matched exactly what Einstein's relativity predicted. And it's not only airplanes. Satellites in orbit carry precise clocks that tick differently than ours. They move quickly through space, which slows their time, but they also feel less gravity than we do on Earth's surface, which speeds their time up. These two effects, one pulling time slower, one pushing it faster, nearly cancel each other out, but not entirely. GPS engineers must adjust for these shifts daily, or your phone's location could drift miles off course. What's beautiful about this is how ordinary it feels to the clocks themselves. Neither the traveling nor the resting clock senses any change. If clocks could think, each would insist it kept perfect time. It is only when they meet again, side by side, that the difference emerges, like two friends comparing notes and realizing they've lived slightly different versions of the same day. Think of your own life as a clock in motion. When you walk, run, ride in a car, or fly across the sky, your seconds lengthen ever so slightly compared to those who remain still. You will never feel it, never notice it, yet it is part of the truth of your time. And here's the most poetic part. This isn't limited to machines. Your body, your thoughts, your heartbeat, they all follow the same rules. When astronauts spend months aboard the International Space Station, they return to Earth a fraction of a second younger than if they had stayed home. They have, in a very real sense, lived a different amount of time. If we could take this idea further, if we could travel faster and faster, approaching the speed of light, the differences would grow profound. Years could pass for those at home, while only months pass for the traveler. The two clocks would no longer just disagree, they would tell completely different stories. But even here, at the speeds we live with daily, the principle holds. Time is not a rigid beat. It bends gently to your motion, shaping a private rhythm for each journey. The next time you see a train pull away or a plane rise into the clouds, imagine the invisible shift beginning at that moment. The clocks on board are entering a slightly different stream of time, and when they return, they will carry the quiet evidence with them. And so the universe keeps its patient record, not in hours and minutes, but in the way every path through space draws its own path through time. No two are exactly alike, which leads to another thought. If speed can reshape time for a clock, what happens to people who live in that world every day? What does it feel like to carry time's stretch inside your own skin, not just as a measurement, but as a lived experience? The astronaut's secret far above Earth. Astronauts drift in silence, moving faster than any car or train. Yet their speed bends time, giving them seconds we on Earth cannot claim. It's not magic, but physics, and it makes them ever so slightly younger. We follow them through the quiet corridors of orbit. Far above the noise of cities, beyond the curl of clouds and the sweep of wind, there is a place where seconds take a slightly different shape. It is a place where the Earth is not beneath your feet, but all around your view, a blue and white marble turning slowly under the dark dome of space. Here, astronauts live in a world of constant motion, even in stillness. On the International Space Station, they circle the planet at over 28,000 kilometers per hour. From the windows, sunrise and sunset come every 90 minutes. Day and night flicker past like the soft blinking of an eye. And yet, within their bodies, a quieter transformation is taking place, one they cannot feel, but physics can measure. Because of their speed, the astronauts' clocks, whether mechanical, digital, or the beating in their chests, run just a touch slower than ours on Earth. Not by much. The difference is tiny, a fraction of a second over months. But the fact is inescapable. When they return, they are younger than they would have been had they stayed on the ground. This is time dilation in living form. The faster you move, the slower your time flows compared to someone at rest. It isn't magic, it's woven into the laws of the universe. Every circuit of the planet, every silent drift above the continents stretches their seconds out just a little longer. If you were to meet an astronaut the day they left and again the moment they returned, you'd see no difference. They would have aged in your eyes as any traveler might. But precise instruments, atomic clocks, would whisper the truth. Their journey carved a tiny delay into their personal timeline. And speed is only part of their story. Up there, gravity's grip is weaker. The further you are from Earth's center, the less its pull slows your seconds. This effect pushes their clocks to tick a little faster than ours, an opposite tug against the slowing caused by their speed. The result is a delicate balance, two invisible hands on time's dial, pushing in different directions. Physicists have measured both. The speeding station stretches their seconds, the reduced gravity compresses them. When the math is done, the slowdown from speed wins, leaving astronauts ever so slightly younger than their Earth-bound twins. Think of this. Every orbit is a brushstroke in their personal portrait of time. They carry a version of now that is not quite the same as yours, separated by billionths of seconds but entirely real. In the vast ledger of the universe, those seconds are recorded with perfect care. And yet, the astronauts themselves feel nothing unusual. They wake, work, eat, sleep, laugh, all in rhythms that feel perfectly normal. Relativity is silent in the body. Its truths arrive only in the comparison. Only when two clocks meet again or two lives rejoin after moving apart do the differences reveal themselves. It's easy to think such small numbers are unimportant, but they are reminders that time is not a single thread spun evenly for all. It is a weave of many threads, each shaped by the path it takes. Astronauts live this truth without fanfare. While the world watches their spacewalks, their repairs, their experiments, another experiment runs quietly inside their cells. Every heartbeat they have in orbit belongs to a slightly slower stream of time than yours. If we could push this effect further, if we could send them near the speed of light, the differences would no longer be fractions of seconds but years. They could leave on a journey and return to find that decades had passed for those they left behind. This is the heart of the twin paradox. Two people born together, aging apart, not by choice, but by the invisible architecture of the cosmos. In the station, though, the change is subtle. A soft, steady reminder that the universe keeps its own kind of fairness. No matter who you are, where you are, or how fast you move, you live your own version of time. No one can borrow or steal another's seconds. You can only travel through them at your own pace. When astronauts return to Earth, they carry this invisible gift with them. They have been away from our exact stream of time, and yet they step back into it as though nothing has changed. They hug their families, breathe air thick with Earth's scents, and look up at a sky that now holds the place where they lived for so long. The difference in their clocks is invisible to everyone, but the instruments that can see time's smallest details. And here is the quiet truth. The same laws that bend their seconds also bend yours. Every step you take, every journey, every change in speed is a thread in your own personal weaving of time. Astronauts simply live far enough from the ordinary to let us notice. Now that you've met them in the silence of orbit, you may wonder, if even the smallest journeys can shift time, what about the movements we barely think about? The walk to the corner cafe, the train ride to work, the slow drift upward in an elevator, do these too write their own tiny edits in the book of your life? Your morning coffee and time dilation. Even the smallest journeys, a walk to your favorite cafe, a short drive through quiet streets, shift your clock. The effect hides deep in the decimal places, far beyond what your senses can feel. Yet it is proof that every motion is a conversation with time. Every step is a ripple in your personal river. You wake to a still morning. The air is cool, the streets are hushed, and somewhere nearby the smell of roasted coffee is beginning to drift. You decide to walk to your favorite cafe, the one with soft music and the corner table you like. It feels like an ordinary morning, but as soon as you start moving, something unseen begins to happen. Your seconds, in the tiniest possible way, start to stretch. No one around you can notice it. You can't notice it yourself. Your body feels the same, your pace unremarkable. Yet from the perspective of the universe's patient bookkeeping, your movement has made a difference. Every step you take is part of a private conversation with time. This is time dilation at its most humble. When you walk, you are moving through space, and because space and time are stitched together into a single fabric, you are also moving through time a little differently than someone standing still. The faster you move, the slower your clock ticks compared to theirs. The effect is so small at walking speed that it takes the finest instruments in the world to measure it. But it is there, written into reality as firmly as the pull of gravity. Imagine two versions of you on this morning. One sits at home, still in bed, reading. The other walks to the cafe. When you meet again, the walking you will have aged a fraction of a fraction of a fraction less than the one who stayed still. It's a difference far smaller than a blink, but it is real, and it belongs to you. This is the same principle that shapes the astronaut's days in orbit, only scaled down to the speed of daily life. They move at thousands of kilometers per hour. You stroll at a few. The math is different, but the rule is the same. Motion changes time's flow. And here's where the beauty lies. You don't have to feel it for it to matter. The fact that it happens at all is a reminder that you are woven into the same physics that govern the turning of planets and the flight of light across the galaxy. Even your quiet morning walk is connected to the vast rhythms of the cosmos. There's a second player in this scene too, gravity. Your cafe might be just a few meters higher or lower than your home. Clocks higher above the Earth's surface tick ever so slightly faster, because gravity tugs on time, slowing it near the ground. So if your walk takes you up a hill, you are not only changing your time by moving, but also by climbing into a place where gravity's hold is a tiny bit weaker. All of this unfolds without ceremony. You reach the cafe, the bell over the door gives its soft ring, and the smell of coffee wraps around you. You order your drink, settle into your seat, and look out at the street. The morning is unchanged, and yet, in a way so subtle it borders on poetry, you are now living in a slightly different now than the person who stayed behind. You can think of time as a river, with each person floating along in their own narrow channel. Most channels run side by side, nearly matching in speed. But every choice, every motion, every change in position alters the way your channel flows. In small ways, your walk to coffee this morning has taken you on a path through time no one else will ever exactly share. It's strange to realize that you've been bending time your entire life without knowing it. The games you played as a child, the errands you ran last week, the moments you hurried to meet someone, each one wrote a tiny change into your clock story. You have always been a traveler in time, even without spaceships or grand adventures. And if this is true for you, it's true for everyone. The people passing on the sidewalk, the cyclist crossing the street, the barista behind the counter, each is carrying a unique timeline, their seconds shaped by every step and motion. We live side by side, yet each of us inhabits a slightly different universe of moments. You take a sip of your coffee, feeling its warmth spread through you. Outside, a bus rolls past, a runner jogs by, a delivery truck hums down the street. Each is traveling at its own pace, writing its own tiny edits into the book of time. From the cafe window, it all looks ordinary, but you now know it is anything but. And so your morning ends with a quiet realization. Time dilation is not some rare effect reserved for astronauts and experiments. It is happening all the time, all around you, woven into the smallest motions of daily life. The difference may be invisible, but it is constant, a whisper of the universe's true nature. Which raises a new thought. If time can be bent by walking to get coffee, what happens when the change is not just in speed, but in the place itself? What does it mean when the height of mountains, the depth of valleys, or even the pull of the earth beneath you begins to shape the seconds you live? The breadth of mountains. High in the mountains, clocks tick faster than they do at the sea. The difference is invisible to your eyes, but real enough for the universe to count. Altitude changes gravity's grip, and gravity changes time's flow. Standing on a peak, you are living a slightly faster life. The air is thinner here. It moves differently in your lungs, light and cool, almost sharp. The horizon stretches farther than it does in the lowlands, and the clouds feel close enough to touch. You are standing on the shoulder of a mountain, and without realizing it, you have stepped into a place where time itself moves at a different pace. Down at sea level, gravity's pull is stronger. The weight of the Earth's mass tugs at every atom, bending not just space, but time. Up here, farther from the planet's center, that pull is ever so slightly weaker. And in the quiet mathematics of the universe, weaker gravity means faster time. It's not something you can feel. You don't stand on the peak and watch seconds pour past more quickly, or feel hours slide away like water over rock. To you, your heartbeat is the same, your breath is the same. But if we placed a perfect atomic clock at your feet and another far below in the harbor, they would begin to drift apart. The mountain clock would run ahead. The difference is small, billionths of a second over a day. But it is measurable and it is real. In physics, this is called gravitational time dilation. Einstein's general theory of relativity showed that gravity and time are bound together. The stronger the gravity, the more time slows. The weaker the gravity, the more time quickens. When you climb a mountain, you are not only changing your view, you are changing your relationship to time. It's as if the Earth is gently loosening its hand from your seconds, letting them slip away a little more freely. This isn't just theory. Physicists have tested it with clocks at different heights in the same building. Even a shift of a few meters is enough for the clocks to tick out of sync over time. Up here on the mountain, the effect is greater. Not by much, but by enough for the universe to keep perfect record. And so, without any spaceship or high-speed travel, you are already living a different timeline than someone at the beach far below. If you stayed here for a lifetime, you would be ever so slightly older than your twin who lived by the sea. Not by minutes, not even by seconds, but by tiny slivers of time too small for human senses to catch. It's a quiet reminder that time is not something you own. It is something you share with the world around you. And your portion of it shifts with the land beneath your feet. Think of the mountain as breathing. The valleys are its slow inhale, drawing time in tightly, holding it close under the weight of gravity. The peaks are its exhale, letting time drift out into the thinner air, light and unbound. Standing here, you are part of that breath. You can imagine it now, an invisible contour map, not of height, but of time itself draped over the landscape. Every hill, every ridge, every summit changes the pace of the seconds that pass there. A traveler on foot or by car unknowingly moves through these gentle shifts, carrying their own personal timeline like a shadow. And perhaps the most humbling part is this: the same rules apply across the universe. On the surface of a dense planet, time crawls more slowly. Far from any mass, out in the empty dark, it runs more quickly. If you could stand near the event horizon of a black hole, your seconds would stretch into near eternity for someone watching from far away. The mountain is only a whisper of that effect, a small note in the vast music of time. As you stand here looking down at the valleys and rivers below, you might think about how many versions of now are playing out at this moment. The fisherman at the coast, the child in the hill town, the pilot passing high overhead, each is living by a clock tuned ever so slightly differently. We share the same sun, the same sky, yet we are all quietly drifting through our own versions of time. And that brings a new curiosity. If speed can stretch time and height can loosen it, what happens when you chase the fastest thing of all? What if you tried to keep up with light itself, not to catch it, because you never can, but to see how it changes your seconds as you approach? Racing light, without ever catching it. The faster you move, the slower your time flows, but there is a limit you can never pass. Light is that limit, a horizon no traveler can cross. Chasing it stretches your seconds, lengthens your minutes, and makes your clock unlike any other. And yet, no matter how fast you go, light will always stay just out of reach. Imagine the fastest thing you know. A jet slicing through the air, a bullet leaving the barrel, the International Space Station sweeping across the sky. Now imagine something that leaves all of these behind without effort. A beam of light. It moves at 299,792 kilometers per second, enough to travel around the Earth more than 7 times in a single heartbeat. And in the laws of physics, as Einstein saw them, nothing with mass, no person, no spacecraft, no particle, can ever reach that speed. But you can try to get close, and the closer you get, the more time begins to change. If you could ride a spacecraft that accelerated smoothly toward the speed of light, you would feel nothing unusual inside. Your heart would still beat steadily, your thoughts would unfold at the same pace. From your own perspective, nothing has slowed. But to those watching you from far away, it would seem as if your seconds were stretching, your movements unfolding in a slow, deliberate rhythm. This is time dilation in its most dramatic form. At ordinary speeds, a walk, a car ride, even a journey around the world, the effect is microscopic, but at a significant fraction of light speed, it becomes profound. You could travel for what feels like a single year to you, only to return and find that decades have passed on Earth. It's as if your personal river of time has slowed to a gentle crawl, while the rest of the world's rivers have surged ahead. Physicists have seen this effect in nature. Particles called moons are created high in the atmosphere when cosmic rays strike air molecules. At rest, they decay in microseconds, far too quickly to reach the ground. But they are born moving close to the speed of light, and time dilation stretches their lifetimes enough for them to complete the journey down to Earth's surface. Without relativity, we would never see them here at all. The idea is both humbling and thrilling. The universe is built so that speed and time are inseparable partners. The faster you move through space, the slower you move through time. This is why light itself is so strange. It moves through space perfectly, but through time, not at all. From light's perspective, every journey is instantaneous, and so the speed of light is not just a number. It is a wall, a boundary written into the fabric of reality. No matter how hard you push, you can only approach it. The closer you get, the harder it becomes to gain speed. The energy you pour in goes not into making you faster in the way you expect, but into stretching your time further and further. This is why the dream of chasing light feels more like chasing the horizon, a goal that shifts away as you move toward it. You can narrow the gap, but never close it. And yet, in that pursuit, your seconds become different from everyone else's, lengthened and rarefied like air at the top of a mountain. If you could look out your spacecraft window as you neared this limit, the universe around you would appear transformed. The light from the stars ahead would shift bluer, compressed by your motion. The light behind would redden, stretch thin. The world would warp and bend, not because space itself is playing tricks, but because time and space are one, and you are moving through them differently. It's a beautiful paradoxical truth. In trying to catch the fastest thing in existence, you slow your own time the most, and while you may never overtake light, the journey toward it changes you forever. When you return from such a voyage, stepping back into Earth's gravity and air, you would carry a story in your very cells, a story of years lived differently from those you left behind. They will have aged more, you will have aged less. You will share the same moment again, but you will have traveled through different depths of time to get there. And here's the quiet wonder. Every motion you make, from walking to running to orbiting the planet, is a faint echo of this truth. Chasing light is only the extreme case, the edge of the map. But even now your life is shaped by these same laws, gently, invisibly, which invites a new question. If speed can stretch time so far that years turn into moments, what happens when we bring gravity back into the picture? Not the soft pull of mountains or earth, but the crushing grip of the universe's most extreme objects. When speed and gravity dance together, speed slows time, gravity slows time. Together they weave a double spell. Near immense masses, seconds stretch thin. At high speeds they stretch even more. Orbiting a black hole or skimming the edge of a neutron star, time itself becomes almost still. Here, motion and weight are partners in the slow dance of the cosmos. Imagine the pull of the earth holding you steady where you stand. Now imagine that pull growing stronger, not just twice as strong, not 10 times, but millions of times greater, until even light cannot escape. This is the gravity of the universe's most extreme places, the dense skin of neutron stars, the invisible edge of black holes. Here, gravity alone can make seconds lengthen into minutes for those watching from far away. Now add speed to the picture. When an object orbits a massive body, gravity pulls it inward, while speed flings it outward, and the two forces find a strange equilibrium. But in Einstein's universe, both forces also bend time. Gravity slows it because space-time is curved so steeply that even the passage of moments becomes stretched. Speed slows it because, in moving quickly through space, you move more slowly through time. In the most extreme environments, circling a black hole, skimming over the surface of a neutron star, these two effects do not cancel each other. They conspire. Seconds for you become longer and longer compared to those of someone far away in the open void. If you could watch yourself from a safe distance, you would see a version of you moving in slow motion, your gestures unfolding like a leaf drifting to the ground. But inside your own body, everything would feel the same. Your heartbeat, your breath, your thoughts, all in the normal rhythm you have always known. Time dilation never announces itself to the traveler. It is revealed only when two journeys meet again. Astronomers think of this when they study the accretion disks around black holes, great spinning rings of gas and dust heated to unbelievable temperatures. Material here whirls at close to the speed of light, deep in a gravity well that distorts space-time like a heavy ball sinking into a rubber sheet. In that realm, minutes for the spinning matter could mean hours, days, or even years in the wider universe. The same principle plays out in less violent places too. Satellites in low Earth orbit experience both effects. Speed slows their time, while being closer to Earth's mass slows it further. The difference is tiny here, but the dance is the same. Gravity and speed moving together, changing the shape of seconds. If we could harness this double bending of time, the possibilities would be as strange as they are unsettling. You could live in a place where years pass in the universe, while only days pass for you. It would be a kind of time travel forward, not by leaping, but by waiting in the right place. But there is a cost to such waiting. Extreme gravity comes with danger, crushing forces, blinding radiation, the constant risk of falling past a point where not even light returns. It is a reminder that the most profound effects in physics are often paired with the most unforgiving conditions. Still, the thought lingers. Somewhere out there, near the edges of stars and the mouths of black holes, time is flowing at a crawl. Events in those places are being stretched into long, slow tapestries, while the rest of the universe rushes on. A single moment there could hold the quiet of centuries elsewhere. And yet, whether in the deep well of gravity or the high sweep of speed, you are still yourself, still bound to your own sense of now. Your clock ticks normally in your hands. It is only when you step away, when you return to the wider world, that the truth emerges. You have been living in a different river of time. Which leads us to a deeper reflection. If every place and every speed in the universe has its own unique tempo, then each life is a private song, measured in beats only it will ever know. What does it mean then to compare one life's length to another's, and how can we think of time as a single thing when it is so clearly many? Your life in two timelines. If you and someone else take different paths, one still, one moving, you live in two versions of time. Each is real, each is yours, yet they will never perfectly match. Clocks may reunite, but the seconds they've counted tell separate stories. This is the quiet split that happens every time lives move apart. Picture two people born in the same moment. They share their first breath, their first cry, their first sunrise. In that instant, their clocks, whether you imagine them as watches, heartbeats, or some deeper rhythm, are perfectly aligned. For a while they stay together, walking the same streets, waking to the same mornings, measuring life in the same pace of days. Then something changes. One stays home, the other begins to travel. Perhaps the traveler moves quickly, flying across oceans, orbiting the planet, or drifting through space. Perhaps they climb high into the mountains or sink deep beneath the sea. Whatever the path, the simple act of moving, of shifting position in the universe, alters the rhythm of their seconds. From the inside, each life feels perfectly normal. The one who stayed feels no shortage or surplus of time. The traveler feels no stretch or squeeze in their days. But the two have begun to live in different timelines, separate threads in the same fabric, each weaving its own pattern. When they meet again, they will see the same world, speak the same language, laugh at the same jokes. And yet their clocks will not quite agree. The difference may be no more than a fraction of a second, or, in extreme cases, it could be years. It is a divergence that neither can feel in the moment, but that the universe measures with perfect precision. This is the heart of relativity as it touches human life, the recognition that time is not a single shared stream, but a network of currents. We can cross into each other's waters, but we cannot carry exactly the same journey. In a sense, we all live in two timelines, the one we feel inside and the one others measure from outside. Your inner time is personal and constant, tied to the beat of your heart and the flow of your thoughts. Outer time, the one written by the universe, shifts with your motion and your place in the gravity field. Most of the time, these differences are so small they dissolve into the noise of daily life. But they are always there, shaping your unique footprint in the cosmos. Imagine for a moment your own life as a branching path. Every journey you take, from crossing a street to flying across the world, sends you into a slightly different timeline from those who remain still. Every reunion is, in truth, the meeting of two separate versions of now. The twin paradox makes this visible in thought experiments. Send one twin on a near light-speed journey to a distant star, and they return younger than the one who stayed behind. Both have lived every moment of their lives fully, but their lives have contained different amounts of time. There is no true clock to reconcile them. Each timeline is real in its own right. You don't have to travel between stars to experience this. Right now, people in planes above you, satellites overhead, and friends across the world are all living moments slightly out of sync with yours. When you speak to them, you share a present that is already subtly divided. It's a humbling thought. The concept of the same time is always an approximation. We agree to it for the sake of living together, working together, loving together. But underneath, time is personal, bent and shaped by each path taken. And if every path leads to its own tempo, then perhaps the length of a life is not measured only in years, but in the way those years are traveled. The richness of a life may lie as much in the root as in the clock's tally. Which brings us to a question both scientific and deeply human. If every journey creates its own time, how do we measure the truth of what happened along the way? And how do we know for certain that the clocks, whether in metal, glass, or flesh, are telling us the same story? Experiments in time. Physicists have tested time dilation with airplanes, satellites, and atomic clocks. Each experiment acquired proof that our seconds are not universal. We watch these clocks tick apart, each telling its own soft version of reality, and we see science's patience in capturing time's secrets. The most profound shifts in our understanding of the universe are often confirmed not in grand bursts of light, but in the quiet precision of a measurement. Time dilation, the stretching and shrinking of seconds, began as an idea whispered by Einstein's equations. For years it lived mostly in thought experiments, beautiful in theory, but waiting for proof in the world we could touch. That proof would arrive slowly, in experiments designed with extraordinary care. One of the first great tests happened in 1971, in what came to be called the Hufele-Keating experiment. Physicists took 4 of the most accurate timekeepers of their day, cesium beam atomic clocks, and sent them on commercial jet flights around the world. 2 flew eastward, 2 westward, while identical clocks stayed behind at the U.S. Naval Observatory. When the airborne clocks returned, they no longer agreed with the ones on the ground. The differences were small, billionths of a second, but exactly what relativity predicted. The eastward clocks, moving with the Earth's rotation, lost time. The westward clocks, moving against it, gained time. It was a quiet, almost invisible victory. A reminder that Einstein's strange picture of time was not just a mathematical curiosity, it was the world's reality. Years later, satellites would turn this into daily necessity. The GPS network, a constellation of machines orbiting high above us, depends on clocks so precise they can lose no more than a billionth of a second per day. But those clocks do not tick in harmony with ours on the ground. Their altitude puts them in weaker gravity, which makes them tick faster. Their speed around Earth makes them tick slower. The two effects don't perfectly cancel. The net result is a drift that, if uncorrected, would throw GPS readings off by kilometers each day. So the system's designers build Einstein's relativity right into the code. Every time you check your location on a phone, every time a delivery truck finds the right street, you are depending on the fact that scientists have learned how to listen to time's bending. The test became more delicate still. In 2010, researchers at the National Institute of Standards and Technology in Colorado set 2 atomic clocks just 33 centimeters apart, one slightly higher than the other. Even in that tiny height difference, gravity's hand could be felt. The higher clock ticked faster than the lower. The result was so exact that it proved something extraordinary. Not only does time change for astronauts and satellites, it changes between your head and your feet. And the experiments continue, reaching for finer and finer threads of reality. Some use moons, subatomic particles created in the upper atmosphere by cosmic rays. Moons decay quickly, in millionths of a second. But when they move near light speed, they live longer, not because their decay slows in their own frame, but because their time is stretched from our point of view. Every moon that survives long enough to reach a detector at the Earth's surface is another quiet confirmation of relativity. It is almost poetic how patient these tests must be. You cannot watch a clock in your hand and see it slow. You must move it away or move yourself and then reunite them, comparing their separate journeys through space-time. Only then does the difference emerge. A tiny but undeniable shift in the tally of moments, and though the numbers are small, they carry a vast meaning. They tell us that time is not one shared rhythm for all of reality. Each clock has its own version of the story, shaped by speed, shaped by gravity, shaped by its path through the cosmos. Perhaps most quietly of all, these experiments tell us something about ourselves. We too are clocks. Biological ones, imperfect but steady enough to live by. When we move, when we change our altitude, when we travel, our bodies keep their own private pace, just like the instruments. We return from every journey, whether across town or across the world, carrying a version of time that is uniquely ours. The patience of science has made these invisible differences visible, and in seeing them, we have learned to trust that the strange things the universe whispers to us are worth believing. From the cold precision of atomic clocks, we now turn inward to a different kind of experiment, one that needs no jets, no satellites, no laboratory. An experiment you can perform here and now, in the quiet of your own breath. One that shows that even without changing the physics of time, you can change how it feels. The quiet between heartbeats. When you slow your breath, time feels different inside you. It's not relativity, but perception, your mind reshaping seconds. We linger here to notice how body and brain tell time together, and how this too is a kind of time travel. Close your eyes for a moment, let your breath deepen, flowing in as if it has all the space in the world, and drifting out even more slowly. With each inhale and exhale, the room around you softens. The sharp edges of sound grow rounded. The air itself seems to grow still. Now listen inward. Your heartbeat is there, steady, quiet, like the footsteps of a companion who never leaves. There is a pause between each beat, and in that pause something opens, a small silent chamber where the world waits. This is not the bending of time in the way Einstein described. You are not changing the physics of the universe, but you are changing the way you experience it. Your mind in this moment is stretching each second like warm taffy, making more room inside it. Neuroscientists speak of the brain's internal clock, not a single organ, but a network of rhythms. It lives in the firing of neurons, in the rise and fall of chemicals, in the gentle sway of our circadian cycles. When you rush, this clock speeds up. When you slow, it lingers, giving each moment more weight. You have felt this before. A stressful morning collapses in on itself, hours disappearing into a blur. A calm afternoon in the sun seems to last twice as long as the clock insists it does. Nothing in the outside world has changed. It is your inner timekeeper adjusting the scale. Meditation and mindful breathing work on this principle. By drawing attention to your breath, you take hold of the wheel of your own perception. Each inhale marks the beginning of a moment. Each exhale marks its end. The slower you steer this rhythm, the more spacious time feels. It is a kind of personal time travel, not forward or backward, but inward. You step into the present moment as though it were a room with no walls. Here you are no longer measuring life by the clock on the wall, but by the tides within you. The quiet between heartbeats becomes your smallest unit of time, and yet in that fraction of a second, you can feel the entire texture of now. The softness of your breath, the warmth of your skin, the stillness of the air. It is here, in these pauses, that your awareness has the freedom to expand. This inner slowing has no impact on the world's physics, yet it changes your life in a way just as real. A minute lived in awareness is fuller than an hour spent in distraction. The memory of it is denser, richer, as though it contained more life. And perhaps this is why moments of danger often feel longer. In those times the brain floods itself with attention, recording everything, the sound, the light, the smell. It is as if perception opens its shutter wide, letting in more frames per second. The external clock does not slow, but your experience of time does. You can choose this deliberately. You can make an ordinary walk, a meal, or a simple breath feel longer, deeper, more complete. And while it will not add years to your life, it may add life to your years. In this way, you discover that time is not only a physical property of the universe, it is also a landscape in your mind. You can wander in it slowly, noticing the leaves on the trees, the sound of a distant bird, the way your own thoughts rise and fade. Or you can race through it, barely touching the ground. Both are valid. But knowing that you can choose your pace, even in a world that moves fast, is its own kind of freedom. And here is the link to the rest of our journey. If you can change your sense of time without leaving your chair, imagine how profoundly it changes when you leave Earth entirely. When you step into the vastness of space, moving at speeds where physics itself begins to stretch the seconds, perception and reality join hands. Living longer in the stars. Imagine a future where people live part of their lives on fast-moving ships. They return to find Earth's clocks have leapt ahead. This is more than science fiction. It's a path physics allows. We drift into this possibility, feeling its bittersweet edges. Picture the harbor of tomorrow, not with sails and masts, but with great silver ships resting in orbit, ready to slip into the dark lanes between the planets. They are built for long journeys, their engines humming with patient energy, their hulls holding small worlds within. And aboard them, people live and work, carrying their own private streams of time. From the moment these travelers leave Earth, the rules begin to change. Their ship's speed bends the seconds they live, stretching them longer compared to those who remain behind. To the crew, the days and weeks feel ordinary. They eat, sleep, share stories, mark birthdays. But back on Earth, the same span of time is passing more quickly. Physics does not frame this as magic or miracle. It is the natural outcome of motion through space-time. The faster you move, the slower your clock ticks in comparison to a clock at rest. It is the same truth that shaves billionths of a second from the lives of astronauts in orbit today, magnified by speeds far greater than anything we have yet achieved. Imagine leaving Earth on a voyage to a nearby star, your ship traveling at 90% of the speed of light. For you, the journey there and back might last 10 years. But when you step again onto the soil of Earth, decades will have passed here. Children you knew will have grown old, cities will have changed, some faces you longed to see may be gone. This is the paradox of such travel. You have lived longer by your own clock, but you have lost years in the shared world you left behind. You have gained time in your own body while surrendering it in the lives of others. In stories, this is often told as tragedy, the lonely traveler who returns to find themselves a stranger in their own home. But there is a quieter way to see it. You have, in a sense, touched two eras with the same hands. You have stood in a single breath between what was and what has become. For those who choose this path in the future, life will be a balancing act between longing and discovery. They will know that each journey is also a kind of farewell, that the world they return to will not be the one they left, and yet they will go, drawn by the pull of exploration, by the desire to see not just distant places, but distant times. Perhaps communities will form among the stars, families and friends whose shared time runs slower than Earth's. They will measure history differently, marking the passage of centuries on their home world, while only decades pass for them. To Earth, they will seem like visitors from the past. To themselves, they will feel entirely of the present. The mathematics is clear, but the emotions are not. For every traveler who returns, there will be reunions both joyful and bittersweet, laughter over new stories, silence over the years that cannot be regained. And one day, someone may leave on such a voyage knowing they will never return. Not because the ship will fail, but because by the time they come back, the Earth they knew will be a memory in history books. They will live out their days under a different sun, carrying within them a clock that ticks to its own rhythm, untethered from the pulse of the planet. It is easy to think of this as loss, but perhaps it is also a gift, a reminder that life is not measured only in how many years pass, but in what is found within them. And so the travelers of the future will live with a deep truth. Time is not a universal inheritance. It is something each of us earns second by second on the path we choose through the cosmos. Which brings us to the edge of time's greatest test, the places where speed alone is not enough, where gravity steps in to bend the seconds almost to breaking. There, near the most extreme objects in the universe, time slows so much that a single minute for you could be centuries for those watching from afar. The edge where time breaks. Near black holes, time stretches into near eternity for the traveler. Minutes for you could be centuries for someone watching from afar. This is time dilation pushed to its limit, where reality splits in two. And we stand at this edge, looking into the slow abyss. There is a place in the universe where time nearly stops, not in the sense of broken clocks or sleeping worlds, but in the deep bending of reality itself. Here, gravity is so intense that even light cannot escape. Here, the seconds you carry in your body are stretched into vast distances for anyone watching from far away. This is the realm of the black hole, a concentration of mass so extreme that it tears the fabric of space-time into a steep, plunging well. The edge of this well is called the event horizon. Cross it, and you are gone from the universe's visible story. Hover near it, and time begins to change in a way that feels like a trick until you understand the truth. From your own perspective, everything is normal. Your heartbeat is steady, your breath unchanged. If you could glance at your watch, its hands would sweep as they always do. But to someone observing from far away, your movements would slow, your voice would deepen, your image would stretch. The closer you drift to the horizon, the slower you appear to move, until you seem frozen in place. It is not an illusion. It is the nature of space-time under extreme gravity. Einstein's equations predict it, and the physics leaves no room for escape. Gravity slows time. Here, the slowing is pushed to its final limit. Add motion to this gravity, orbiting the black hole at tremendous speed to avoid being pulled in, and the effect deepens. Speed slows your seconds, gravity slows them further. Together they stretch time until it becomes almost still. In such a place you could spend mere minutes circling the abyss and return to find centuries have passed elsewhere. The world you left would be gone, its histories written without you. Some scientists have imagined what this would look like. The light from the universe beyond would appear warped, bending into strange shapes around the black hole. Stars would seem to smear and dance along its curved edges. Time outside would race ahead, so that from your vantage the galaxy would seem to be living in fast motion, stars forming, dying and disappearing in the space of your single hour. And yet, inside your own skin, the moment would feel whole and steady. You would not sense the stretching of time because you are bound to your own frame of reference. Relativity never changes the way time feels to you. It only changes how your time fits into the larger story. There is a profound loneliness in this. To live at the edge where time breaks is to exist in a kind of exile, separated from the rest of the universe by the pace of your seconds. Even if you could leave and return, the people and places you knew would have moved so far ahead that reunion might be impossible. It is a reminder that time dilation, while fascinating, is not just an abstract curiosity. It is a force with consequences for connection, for memory, for the simple act of sharing life with others. But it is also a place of wonder. Standing at the edge, you are looking into a slow abyss that holds both danger and beauty. The danger of being lost to the universe's gaze, and the beauty of watching reality unfold on two different scales at once. You are here, in your own unbroken moment, and somewhere far away, the rest of the cosmos is racing past, carrying your story forward without you. In this place, the question of how much time do I have becomes strangely fluid. You could have more than anyone else, or less, depending on where you choose to stand. And so, the journey through time dilation reaches its most extreme chapter. From here, there is only one way forward, to turn back from the edges, to step away from the slow pull of gravity, and to return to the steady, familiar rhythm of your own clock. Returning to your own clock. No matter where you've gone or how fast you've traveled, you always return to yourself. Your body's clock, your memories, your rhythm. They welcome you home. And as night falls, you feel the gentle weight of your own time again. It is yours alone, steady and faithful. Every journey through time has an ending. The high arcs around the planet, the long drift through the dark, the close brush with gravity's edge, all of it eventually brings you back. You step off the ship, walk down the ramp, or simply open your eyes from a deep breath. The world meets you again, offering its own rhythm. You notice what's changed. The air feels heavier in your lungs, the light more familiar on your skin. Your surroundings carry the marks of time's passing. A tree grown taller, a street paved over, a face older than you remember. But inside you, your heartbeat is steady, just as it was when you began. This is the quiet truth. No matter how far you've gone, you never stop living by your own clock. It is the most personal timepiece you have, not powered by gears or circuits, but by the gentle electrical pulse of your own life. It has ticked through every journey you've taken, in perfect loyalty to you alone. You carry the memory of the differences you've lived, the time you gained, the time you lost, the ways your seconds have stretched or compressed compared to the world's. But these differences don't change the fact that you've always moved at the speed of yourself. It feels strange at first to return to the pace of the world. If your journey has slowed your time, you step into days that seem to rush ahead, the hours slipping quickly past. If it has sped your time, the world feels unhurried, as if waiting for you to catch up. But soon your body and the planet settle into harmony again. In that settling, there is comfort. The clock you return to is not just the one on the wall, but the one inside you. The rhythm that has measured your life from its first moment. It is a homecoming not to a place, but to a pace. And as night falls, you feel the weight of your own time. It is not the universe's time, not your neighbors, not even your closest companions. It is yours, shaped by every step you've taken, every path you've chosen, every turn in the river of space-time you have drifted through. You realize that this is what all the journeys have been about. Not escaping time, but meeting it, not mastering it, but learning its textures, how it bends, how it flows, how it waits, how it rushes. Lying in the quiet, you can feel the whole arc of the voyage, from your first heartbeat as a clock, to the seconds that shift with speed, to the mountains and stars that stretch your moments, to the edges where time nearly stands still. And now here, back in the steady pulse of your own life, you understand something that was always true. Every version of time you have lived is real, and all of them belong to you. The universe will keep its own intricate ledger of seconds, but your life is not made of numbers, it is made of moments, and the truest measure of them is how they felt as you lived them. Your eyes grow heavy. Outside the night deepens, above you the stars mark their own slow time. You rest in yours, steady and faithful, knowing that wherever you go next, your clock will go with you until the very last beat. The timeless room. After all the journeys, across mountains, through orbit, near the speed of light, you find yourself in a place where time is no longer measured. There is no ticking, no counting, only presence. Here you learn that the meaning of time is not in how much you have, but in how deeply you live. You are back indoors, in a room that feels neither large nor small, neither bright nor dark. There is no clock on the wall. There is no need for one. The air is still, the quiet deep, and your heartbeat is the only sound that matters. You sit and you let the journeys replay in your mind. The first steps you took into the bending of seconds, the moments when mountains loosened gravity's grip, the fast paths near light's speed, the slow arcs around black holes. Each one felt different, but each was still you, still your own river of moments. Here in this room, there is no rush to hold them together. They rest beside each other like books on a shelf, separate yet part of one story. You realize now that you have never truly left your own time. You have only seen how it changes shape when you meet the universe in different ways, and the more you have seen, the more you have understood that time is not a single thing. It is many things, personal, relative, physical, felt. The room around you feels softer now. Perhaps it is the night pressing against the windows, or perhaps it is the way you have let go of the need to measure this moment. You close your eyes. The journeys you've taken fade, not as if forgotten, but as if absorbed, the way the day dissolves into the memory of light and sound when you fall asleep. And in this last moment before sleep claims you, there is only presence. No past to pull you back, no future to pull you forward. Only now, vast, steady, and yours.